So here are some video of common word problems that your student might be facing. So in this first question, it says, which step is in solving 2 3/5 minus 3 4/5? Now before I even start solving, I think to myself, when I add fractions, my denominator always stays the same. So I'm going to be working with this. Well, in A, it says adding the fractions to get 7/10. Again, I know that my denominator is going to stay a fifth, so I can mark out answer choice A. B says changing the number to be added to 3/10 and 4/15. Well, again, I know my denominator must be a 5, so I can mark out answer B. Now, both the C and D are working with this, so now I can go ahead and start my work. So I'm going to rewrite the problem so I can manipulate it. 2 3/5 plus 3 4/5. Now, an easy way to add, we could have gone 3 plus 5 is, 2 plus 3 is 5. 3/5 plus 4/5 is 7/5. Well, a lot of times they're going to say, that is one way, but we're looking for steps. So we want you to change these mixed numbers into improper fractions. And to do so, we do 5 times 2. So we multiply our denominator by our whole number and get the product of 10. Then we add our product to our numerator, and we get 13/5. We go denominator times our whole number, so 3 times 5 gives me a product of 15, plus my 4 in my numerator, and I get 19/5. Now I go back to my answer choices, changing the numbers to be added to 6/5 and 12/5, changing my numbers to be added to 13/5 and 19/5. D would be my correct answer. Number 2 says, which figure correctly shows 1/10 plus 5/10 is 6/10? And before I even start checking, I can automatically cross out answer choice B because it is not showing equal parts, and fractions are always equal parts. So now I need to start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one shows 1/11, but our question is asking us for tenths, so I can eliminate A, which automatically gives me the answer choice of C. But let me check first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/10 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/10 plus 5/10 equals 6/10. It shows exactly what the problem is asking for. Which equation best fits the picture of the chocolate bar partition below? Now, before I even start, I need to figure out partition means, parts. We see that keyword, part. So what equation best fits the broken apart? So first I'm going to count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16/16. This part is 1, 2, 3, 4/16. So I know I'm going to be working with 4/16 and 16/16. Now if I look at my bar, we can see that it's broken into 1, 2, 3, 4. So it's broken into fourths if we would like to see it that way. Because 4/16 is equal to 1/4. Because 4 can go into 16 4 times. 4 can go into 4 1 time. So 4/16 is equal to 1/4, which might make the kids want to choose A. But A says 1/4 plus 2/4 equals 3/4, and that's what this half of the picture is showing. But it's not talking about this piece missing. So I know I can automatically eliminate A. Well, I had a total of 16/16. We broke apart 4/16, and then we got 12/16 left over. So that is a possibility. Now, 3 is not a factor of 16. So we know we're not going to work with C. So our answer choice is B. Jamel bicycles 3 7/8 miles on Tuesday. He bicycles 4 1/8 mile on Wednesday. How much farther does he bicycle on Wednesday than Thursday? The key words, how much farther, tells me that I am going to subtract. Well, with this question, I can do my step-by-step model drawing. So he bicycles blank more miles on Wednesday, and I'm going to abbreviate that, than on Tuesday. So we know that we have Tuesday, he bicycled 3 7/8, and on Wednesday, he bicycled 4 1/8. And we're looking for this missing portion. So we're going to say 4 1/8 minus 3 7/8. Now when I'm subtracting fractions, mixed numbers, I'm always going to look at my fractions first. 7 1/8 minus 7/8 I cannot do. So I'm going to take a whole and make that a 3. And then I'm going to add 8/8. So now I have 3, and I'm going to add my 8s. 1/8 plus 8/8 equals 9/8 minus 3 7/8. Now the thing that gets a lot of students is that they'll add this 8/8, but they will not take away a whole. So they will add a whole, but they won't take away a whole. But they must take away a whole in order to add that whole. So now if we look here, 3 minus 3 is 0. 9/8 minus 7/8 equals 2/8. Well, 2/8, if I divide both 2 and 8 by 2, I will get 1/4. So now I need to look at my answer choices. A says 1/4, which is what I got, so I'm going to circle A. Many of our students said B because they forgot to subtract a whole when they added their whole. But the correct answer is A because 3 9/8 minus 3 7/8 equals 2/8, which equals 1/4. The chart shows the average amount of food the different dog breeds should be fed each day. We have Chihuahuas should eat 1/3 of a cup, Beagles 1 whole cup, Boxers 2 1/2 cups, and a Mastiff 4 cups. What amount of food in cups that a Chihuahua should be fed in a 7-day week? So we're only looking at a Chihuahua. So we should say a Chihuahua should be fed blank cups in a 7-day week. So we have 1 week. So I'm going to go ahead and draw my bar model. I know I'm looking for the total number of cups. And we are going to divide our bar into 7 days. And this is going to be days. So in 1 day, a Chihuahua should eat 1/3. On the second day, 1/3. Third day, 1/3, and so on and so on. So I do not want to add those 1/3 7 times. So I'm going to go 7 times 1/3. Now going back to our last video where I talked about notes, we're going to take that 7 and put our whole number over a 1, and then we can multiply through. 7 times 1 equals 7. 1 times 3 is 3. Well, we do not like improper fractions, so we're going to see how many times can 3 go into 7. 3 can go into 7 2 times, so that is our whole number. 2 times 3 is 6. 7 minus 6 is 1. So 2 remainder 1, or 2 1/3. Because we take our remainder, and our remainder becomes our numerator and we put it over our old denominator, because in 4th grade we do not change the denominator. Now we're with Tom. Tom bought 6 boxes of toy cards. Each box contains 9 cards. 1/3 of the cards in each box are red. How many cards are red? So we're going to go blank cards are red. We're looking for cars. So I'm going to go ahead and label it with a C for cards. And in our problem, it told us that there are 6 boxes. So I'm going to go ahead and divide it into 6 to represent the 6 boxes. Well, in one box, there are 9 cards. So before I can figure out that 1/3 of them are red, we need to figure out how many total cards there are. So my equation will be 9 times 6, which is equal to 54. Well, now we need to figure out 1/3 of 54. So we know we have a total number of cards. We know that 1/3 is red. So I'm going to make a second box. Again, the total is 54. And we know that 1/3 are red. So we're going to go 54 divided by 3. Now I ran out of room over there, so I'm going to come over here. 54 divided by 3. Well, I can do 3 times 10 is 30. I get a difference of 24. And I know that 3 can go into 24 8 times, which gives me a product of 24, 0. Then I add my partial quotients. 10 plus 8 equals 18. So we're looking for 1/3 of 54, and we get 18. So our answer choice is C.